welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics class, and that is being the classes you for class 11th, and that is being the part 1 of physics, and this has been the classes year 1, which we'll start discussing about the CBSE, which is being the NCERT. And NCERT we are dealing with which part 1, and this part 1 is been consisting of till chapter 8, that is from 1 2 3 4 5 6 7 8 9, sorry 8, and then further from 9 this is from the next part, which has been the part 2 here. So this is the chapter 1, and that what we have to discuss about the physical world. Physical world is the another new chapter, and that is being the important, of course it is been consisting of from NCERT. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So here we go in terms of physical world, which we have to discuss here, that has been the important one. So on the same page for the physical world, which we go ahead, first we'll discuss what is physics. So for the physical world, we have to know what is physics. In case of physics here, that humans have always been curious about the world around them, the night sky, whether it's bright celestial objects that have fascinated the human, that and for the same we have that the night sky, whether it's bright celestial objects that have fascinated humans since it's more real, and that the regular repetitions of the day and night, that the annual cycle of seasons, the ellipses and the tides and the volcanoes, and that the rainbow has always been a source of wonder. The world has an astonishing variety of material and bewildering diversity of life and behavior. The inquiring and imaginative human mind that has responded to the wonder and that awe of nature in different ways. One kind of response from the earliest time that has been to observe the physical environmental carefully, look for any meaningful pattern and relations in natural phenomena, and build and use new tools to interact with nature. This human endeavor that led in course of time to modern science and technology, where in the same case the word science originates from the Latin word scientia, that meaning to know. The Sanskrit word that is your Vijnan, and the Arabic word is your ilm, that convey similar meaning, namely knowledge. Science is a broad sense is an old as human species, and the early civilization of Egypt, India, China, Greece, Mesopotamia, and many other made a vital contribution to its progress from the 16th century onwards, that the great strides that were made in science in Europe. By the middle of the 20th century, that science has become a truly international enterprise with many cultures and contributing to its rapid growth. What is science and what is so-called scientific method, that what we have to discuss here. On the same page, that science is a systematic attempt to understand the natural phenomena in much detail as a depth as possible, and the use of the knowledge so gained that to predict, modify and control phenomena. Science is exploring, experimenting and predicting from what we see around us. The curiosity to learn about the world, unraveling the secrets of nature, is the first step towards the discovery of science. The scientific method that involves the several interconnected steps, which is systematic observation, controlled experiments, and qualitative and that what we'll have to discuss here about the qualitative and quantitative reasoning, mathematical modeling, predictions and verification, and or falsifications of theories. Speculations and conjectures also have a place in science, but ultimately a scientific theory that to be acceptable. must be verified by the relevant observations or experiment. There is much philosophical debate about the nature and the method of science that we need not discuss here. So on the same phase that here that the interplay of theory and observation for the experiment, that is basic to the progress of science, where science is ever dynamic and there is no final theory in science, and no unquestioned authority among the scientists. As observation improve in detail and precisions or experiment that yield new results, theories must account them if necessary by introducing the modification. Sometimes the modification may not be drastic and may lie within the framework of existing theory. For example, when Johannes Kepler in 1571 till 1630 that examined the existence of the planetary motions that has been collected by Tycho Brahe in 1546 and 1601, the planetary circular orbits in the heliocentric theory, that sun at the center of the solar system, that imagined by the Nicholas Copernicus, and 1473 to 1543, that had to be replaced by elliptical orbits to fit the data better. Occasionally that however the existing theory is simply unable that to explain the new observation, this caused to the major upheaval in science. And in the beginning of the 20th century, it was realized that the Newtonian mechanics, that is your till then a very successful theory that could not explain some of the successful theory that could not be explain some of the most basic features of atomic phenomena. Similarly, that the then accepted that a wave of picture of light that failed to explain the that is your photoelectric effort property, and this led to the development of the radically that a new theory, that is in the quantum mechanics, to deal with atomic and molecular phenomena as well. In the same phase, just as a new experiment that may suggest as an alternative theoretical model, or theoretical advances that may suggest what to look for in some experiments, and that the results of the experiments or the scattering of alpha particles by a gold foil in 1911 by the Ernst Rutherford, which has been 1871 to 1937. He established that the nuclear model of the atom, and which then became the basic of the quantum theory of the hydrogen atom, that is given in 1913 by the Niels Bohr. In that hydrogen atom given by the 1913 by the Niels Bohr, and in 1885 to 1962. So on the same phase, if I talk about it, that just as a new experiment that may suggest an alternative theoretical model, and a theoretical advance that may suggest what to look for in some experiments, and that the results of the experiments of the scattering of alpha particles by a gold foil in 1911 by the Ernst Rutherford, 1871, that what we have, and that in 1885 to 1862 that been Niels Bohr. And on the other hand, that the concept of the antiparticles was first introduced theoretically by the Paul Dirac in 1902 till 1984. In 1930, and confirmed 2 years later by the experimental discovery of positron, which is your anti-electron, by the Carl Anderson. So there are many researchers has been taking place. There are many, that the scientists been played an important role for it. But the physics has been a broad broad classified that we have to discuss, the broad subject we have to discuss. Moreover, we go a deeper, that it will give you more knowledge. Even though science is that the day by day the researchers has been taking progress, and something new is being invented by the scientists. So the physics is a basic discipline in the category of the natural sciences, which also includes the other disciplines like chemistry and biology. And the word physics that comes from a Greek word meaning nature, and its Sanskrit equivalent to the bhatiki, that is used to refer to the study of the physical world. A precise definition of this discipline is neither possible nor necessary. We can broadly describe that physics as a study of the basic laws of nature and their manifestations in different natural phenomena. The scope of physics is described briefly in the we will discuss moreover in the next coming sections as well. Here we remark on the two principles thrust in the physics, that is being the unification and reduction. So basically we talk about two principles thrust in physics. Two principle thrust in physics. So that we have, the first we have is unification, and the second is reduction. So here we go. So for the same we talk about it here, and on the same page that in physics we attempt to explain the diverse physical phenomena in terms of few concepts and laws, and that the effort is to see the physical world as manifestations of some universal law in different domains and conditions. For example, the same law of gravitation that is given by the Newton that described the fall of an apple to the ground, and that the motions of the moon that around the earth, and that the motion of the planet that around the sun. And similarly, that the basic law of electromagnetism, which is Maxwell equation that governs all electric and magnetic phenomena, that attempts to unify the fundamental forces of nature, where that reflects the same as a quest for unification, where a related effort is to derive the properties of the bigger, more complex systems from the properties and the instances of its constituent that is simpler parts. This approach is called reductionism, and is the heart of the physics, where for example that the subject of thermodynamics that developed in the 19th century, that we deal with the bulk system in terms of macroscopic quantities such as your temperature, internal energy, entropy, etc. Subsequently, that the subjects of kinetic theory and the statistical mechanics that interpreted these quantities in terms of the properties of the molecular constituents of the bulk system. In particular, the temperature was seen to be related to the average kinetic energy of molecules of the system as well. Now we'll discuss about scope and your excitement of physics. Scope and excitement of physics. So scope and excitement of physics, in terms of it we talk about it. Yes, we can get some idea of the scope of physics by looking at its various subdisciplines. Basically, there are the two domains of interest, whereas in the macroscopic and microscopic. The macroscopic domain that includes the phenomena as laboratory, terrestrial, and astronomical series scales. A microscopic domain includes atomic, molecular, and that has been a nuclear phenomena. Recently, the domain that has been the intermediate between the macroscopic and microscopic, the so-called mesoscopic physics, and that is dealing with a few tens of hundreds of atoms, has emerged as an exciting field of the research as well. In classical physics, that deals mainly with macroscopic phenomena, and that is include like mechanics, electrodynamics, optics, and thermodynamics as well. Mechanics founds on the Newton's laws of motions, and that the law of the gravitation is to be concerned with the motions of equilibrium of particles, where the rigid, deformable bodies and the general systems of particles, that the populations of the rocket by the jet of ejecting the gases, propagations of water waves or sound waves in that all, and that has been in air, and that the equilibrium of the bent rod under a load, etc., that the problems of mechanism Electrodynamic deals with electric and magnetic phenomena that will deal with electric and magnetic phenomena associated with charged and magnetic bodies. Its basic law were given by Coulomb and Oersted that we have, and in the same way, if we go further, that Ampere and Faraday and encapsulated by the Maxwell in the famous set of equations where the motions of the current that carrying conductor in the magnetic field of the response of the circuit to an AC voltage signal that we have, the working of an antenna and the propagation of the radio waves. So we'll just first draw the theory of an experiment that go hand in hand by physics and help each other, that the progress that the alpha scattering experiment to the Rutherford, and it gave the nuclear model of the atom as well. So we are on the same phase, that the working of an antenna and the propagations of the radio waves in an ionosphere, etc., that are problems of electrodynamics, and that optics deals with the phenomena involving light, the working of telescope and microscope, that colors exhibits by a thin film, etc., that are the topics in optics. And thermodynamics, in contrast to mechanics, it does not deal with the motions of the bodies as a whole. Rather, it deals with the system in macroscopic equilibrium and is concerned with changes in internal energy, temperature, entropy, etc. of the system through the external work and transfer of the heat, the efficiency of the heat engines and a refrigerator, that the direction of the physical or chemical process, etc., that are the problems of interest in thermodynamics. In the same way, the microscopic domain of physical that deals with the constitution and the structures of matter at the minute scale of atom and nuclei, and even lower scales of length as well, and their interaction with the different probes such as electron, photons, and other elementary particles. Like classical physics is inadequate to handle this domain, and a quantum theory is being currently accepted to the proper framework for explaining microscopic phenomena. Overall, the edifice of physics is a beautiful and imposing, and you will appreciate it more as you pursue the subject as well. So we go ahead. We made a table. We made a diagram for it. This is a lead box, a lead block. Here it is. This has been the darkened one. This has been your polonium sample. So it will go here. This has been glass. Then this is also glass. This is your alpha. So here, that when it has been intersect, this has been representing. So for the same, it will be your representing here. This has been microscope, and this is a flash of light. This has been, and while it is your, this has been the angle that they are forming is your um, scattering angle, and this is what you can see here. This has been the gold foil. Okay, and this screen is your fluorescent screen. Okay, so this has been the theory of the experiment that is going go hand in hand in physics and help each other progress. the alpha scattering experiment of Rutherford that gave the nuclear model of an atom as well. With the same, that the direction of the which we'll talk about it, and that is being discussed here on the same, the chemical process that up the problem of interest in the thermodynamics as well. So with thermodynamics, in contrast to the mechanics that does not deal with the motions of the body as whole, rather it deals with the system in macroscopic equilibrium in the concerned with the change in the internal energy, temperature, entropy, etc. of the system through the external work and transfer of the heat, the efficiency of the heat engines and refrigerators, that the directions of physical, chemical process, etc. are the problems of interest in thermodynamics. We are in the same case that the microscopic domain of the physical that deals with the constitutions of the structures of matter, and at the minute scale of an atom and a nuclei, and even a lower scale of length, and the interactions with different probes such as electron, photons, and other elementary particles. The classical physics is inadequate to handle this domain, and a quantum theory is currently accepted as a proper framework for explaining the microscopic phenomena. Overall, the edifice of physics is beautiful and imposing, and you will appreciate it more as you pursue the subject as well. On the same phase, we talk about it. So yes, here that you can now see that the scope of the physics is truly the vast. It covers a tremendous range of the magnitude of physical quantities like length, mass, time, energy, etc. At one end, it studies the phenomena at a very small scale of length, 10 to the power minus 14 meter or even less, involving electrons, protons, etc. At the other end, it deals with astronomical phenomena at the scale of galaxies, or even the entire universe, whose extent is of the order of 10 to the power 26 meter. The two-length scales that differs by factors of 10 to the power 40 or even more. The range of the time that scales that can be obtained by dividing the length scales by the speed of light, which is 10 to the power minus 22 seconds to 10 to the power 18 seconds. The range of the masses that goes from says 10 to the power minus 30 kg, which is mass of an electron, to 10 to the power 55 kg, which is mass of known observable universe. In the terrestrial phenomena that lie somewhere in the middle of this range as well. So for the same we talk about here, and that has been the important one. So with the same references, that where physics is an the exciting in the many ways, that to the someone that to some people, that the excitement that comes from the elegance and universities of its basic theories, from the fact that a new few basic concepts and laws that can explain phenomena that covering a large range of magnitude of physical quantities, to some others that the challenge in carrying out imaginable new experiment to unlock the secrets of nature, to verify or refute theories in thrilling. Applied physics is equally demanding that application, and so for the same, that imaginative new experiment then unlock the secrets of nature to verify and refute the theories and thrilling. Applied physics is equally demanding, and applications and exploitations that physical law to make useful devices is the most interesting and excitement part of the required greatly in ingenuity and persistence of effort. What lies behind the phenomenal progress of the physics is the last few centuries, where the great progress usually accompanies changes in our basic perception. First, it was realized that was for scientific progress and only qualitative thinking, though no doubt important, and is not enough. Quantitative measurements is essential to the growth of science, especially the physics, because the law of the nature that happens to be in the expressible, imprecise mathematical equation. That the second most important insight was that the basic law of physics are universal. The same laws applies in widely different contexts. Lastly, the strategies of the approximation that turned out to be a very successful, most observed phenomena in a daily life as rather complicated manifestations of the basics law. Scientists recognize the importance of extracting the essential features of the phenomena from its less significant aspect. It is not practical to take into account all the complexities of the phenomena in one go. A good strategy is to focus first on the essential features, that discovers the basic principles, and then introduce the corrections to build a more refined theory of the phenomena. For example, a stone and a feather that dropped from the same height do not reach the ground at the same time. The reason is that the essential aspects of phenomena, that namely free fall under the gravity, is complicated by the pressure of an air resistance. To get the law of the free fall under the gravity, it is better to create a situation wherein the air resistance is negligible. We can, for example, let the stone be the feather fall through a long evacuated tube. In that case, that the two objects will fall almost of the same rate, that giving the basic law that accelerated due to the gravity independent of the mass of the object. Where in the same case with the basic laws that can be found, and we can go back to the feathers that introduce the corrections due to the air resistance, modify the existing theory, and try to build a more realistic theory of the objects that falling to the earth under the gravity as well. So we discuss moreover related all the other topics that has been in the next coming class. So here we're gonna end up with physics part 1 for the NCERT, and we had even though started with, as I told you, we started with the chapter 1, which has been the physical world, which we have to discuss here. In physical world, we have to discuss physical world. We had discussed about what is physics, scope and excitement of the physics, as you can see here. The further we talk about physics technologies and society in the next coming class, fundamental forces in the natures of the physical laws as well. And next, after completing unit 1, chapter 1, we'll have to discuss that chapter 2, which has been the units and measurement. That has been the introduction, the international systems of the unit, measurements of length, measurements of mass, measurement of time, accuracy, precision, instruments and the errors in the measurement, significant figures, dimensions of the physical quantities, dimension formulas and dimensional equation, dimension analysis and its application as well. In unit 3, we have to cover up the motions of a straight line, which has been the introduction, positions, path, length of the displacement, average velocity and the average speed, instantaneous velocity and the speed, acceleration, kinematic equations for the uniformly accelerated motions, is relative velocity. In the unit 4, we have to cover up the motions on a plane, which has been introduction, scales and vectors, multiplications of a vector by a real number, additions and subtractions of vector, graphical method, resolutions of vectors, vectors additions, analytical method, motions in a plane with a constant acceleration, relative velocity in the two dimensions, and projectile motions, which has been the uniform circular motion as well. In chapter 5, we have to cover up the laws of motion, where we have to cover up the introduction, Aristotle fallacy, then we have the law of the inertia, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conversations and momentum, equilibrium of the particle, common phases in the mechanics, circular motion, solving problems in mechanics as well. After talking about that, we have to cover up the unit chapter 6, which is in the work, energy and power. In that, we have to cover up the introduction, notions of the work and kinetic energy, which has been the work energy theorem of work. Then kinetic energy, work done by variable forces, the work energy theorem for the variable forces, the concept of the potential energy, the conservation of the mechanical energy, the potential energy of a spring, various forms of energy, the laws of conservation of energy, power and collision. In unit 7, we have to cover the systems on of particles and rotational motion, where we have to cover the introduction, center of mass, motion of the center of mass, linear momentum of the system of particles, vector product of the two vectors, angular velocity and its relation with the linear velocity, torque and angular momentum, equilibrium of a rigid body, moment of inertia, theorem of the perpendicular and the parallel axis, kinematics of rotational motions about the fixed axis, dynamic by the rotational motion about the fixed axis, angular momentum in the case of the rotations about the fixed axis, rolling motion as well. In Unit 8, we have to cover up the gravitation, which has been the introduction, Kepler's law, universal law of gravitation, the gravitation constant, acceleration due to the gravity of the Earth, acceleration due to the gravity below above the surface of the gravitational potential energy, escape speed, Earth satellite, energy of the orbiting satellite, geostationary and the polar satellite, and of course the weightlessness as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion and a comment box. Thank you.